I'm Anil Kumar, sharing with you a question from my subscriber. Let me first thank all the subscribers for posting excellent questions and watching my videos. And I hope solution of this question will help many students. We'll try to understand the concept of finding concavity using second derivative for trigonometric functions in this particular video. The question here is, find point of inflection for f of x equals to tan x within the interval when x is greater than minus pi by 2 and less than pi by 2 by analyzing derivatives. Well, if this condition was not there, by analyzing derivatives, we could have given this answer very easily. Look here. The graph of the function tan x within the given interval is kind of like this, correct? Which has vertical asymptotes at pi by 2 and minus pi by 2, right? So the point of inflection is at the origin, right? Concavity changes from concave down to concave up, right? So that is what the answer is. But now let us see how to use point of inflection, how to use second derivative to get to this answer, right? That's the whole concept. Now what all you need for this is, you should also know what is derivative of tan x. Let me write down here. So what is derivative of tan x? It is secant square x, right? I'm not going to derive it here. You can search for Anil Kumar derivative of trigonometric functions for all these derivatives. What is derivative of secant x, right? So the derivative of tan x is secant square x. What is derivative of secant x? It is secant x tan x. You'll need these two derivatives. Perfect. Okay. You can actually pause the video now, answer, and then look into my suggestions. So let's begin. We have the function fx equals to tan x. Let me write this as y equals to tan x. So dy dx will be equals to secant square x. So that's the first derivative. The second derivative is derivative of secant square x. So we can write d2y dx square is 2 times secant x times derivative of secant x. Okay, so let's take it to the right side. Let me complete it here first. So it is 2 secant x times derivative of secant x is secant x tan x. Okay, so the second derivative which we have is 2 secant square x tan x. We are working in the interval from minus pi by 2 to pi by 2. Now in this interval we know that secant is 1 over cos, right? Secant is 1 over cos, and it is not defined at this, let's look into this part also. Okay, so let's say I should use the same scale anyway. Let's just sketch it like this. I'm just using cos x, right? Secant is 1, I'm sorry, this is sin x. Okay. So you also see that there is a discontinuity. These are the zeros for secant x, right? I should say this is cos x, so 1 over that. So there are discontinuities at pi by 2 minus pi by 2 and plus pi by 2. This is the graph of cos x. So reciprocal will give us discontinuities at this point. However, our interval is in between, so we do not have any critical number because of secant square x, but tan x is 0 at 0, so we have a critical number. Let's say critical value 0, 0. Is that okay? So let's analyze the point where d2y dx square, the second derivative is 0 at x equals to 0, right? So we'll analyze this particular point, the second derivative. Okay. So we have 1, 0, and this 0 is at 0. We are working within the interval from minus pi by 2 to plus pi by 2. Now in this interval, we could take a test point, which is say pi by 4. Correct? So at this test point, we have to check whether the function is positive or negative, whether the second derivative is positive or negative. Secant square x is positive always, right? As far as tan x is concerned, you can see very clearly that at minus pi by 4 it is negative, at plus pi by 4 it is positive. Negative means it is concave down, right? And positive means it is concave up. So the change of concavity is at 0. So that is our point of inflection, right? So therefore, point of inflection is at x equals to 0, right? So that is how we can actually find the answer using second derivative. I'm Anil Kumar, and I hope that helps. You can always share and subscribe to my videos. Feel free to post questions. Thank you and all the best.